good?
Good. Okay, hello everyone. My name is Nathan.
My name is Matthew.
I'm Ethan.
I'm Drew.
And we chose to do a Stirling engine for our computer-aided design project. We felt that it had some interesting real-world mechanical engineering applications, and it would be a good project.
Thank you.
Okay, so y'all leave. Okay.
Are you going to do all of the background and everything? Okay.
All right. So for some of the background that we chose and why we chose this project, what a Stirling engine does is it'll convert thermal energy to mechanical energy. It was patented in 1816 by Robert Stirling. However, it was overshadowed by a steam-powered engine, which just had a lot more energy output. But in the 1950s, engineers went back to it to give it some material improvements as well as manufacturing improvements. And so it became a lot more efficient and even was close to reaching the Carnot efficiency. Okay, so for basically how a Stirling engine is going to work, each of these steps is a 90-degree rotation of the axle. So during the heating in the red chamber, the air undergoes a hot air expansion, so it pushes it down through the expansion. And then during the cooling phase, since all that air went into the cold chamber is then pushed down all the way to the 270-degree rotation. And then the final 90 degrees is the actual contraction, where now the hot air is heated up again. Okay, so the major parts that we decided to divide the entire assembly into is the base, which Ethan did. I did the flywheel, the compression chamber Matthew did, and the motor Drew made. And this is just a liaison diagram. So basically the base plate is connecting all three of the major pieces together, where the flywheel is actually connected in between the motor and the compression chamber. And then a bill of materials. What you can really see from this is that even though a lot of our parts weren't particularly complex, we each did about 8 parts. And there was more complexity in the assembly. And then I'll pass it off to Ethan, who is going to go over the base.
So the base plate was a really important part because all of the other parts connected to it via all of these different screw parts. So if the screws were misaligned, then the other parts would not be able to connect with them properly, and then they would not be able to connect with each other properly. So it was very important that we got all the holes correct on the base plate. And as you can see, it was important for us to use geometric tolerancing to make sure that these parts fit together properly. Otherwise, the axles just wouldn't work. And now I'll pass it off to Matthew.
All right, so I did the compression chamber, and the compression chamber handles the compression of air of both the hot and the cold air. And it boils down to about 3 major parts. In this picture, you can see the outer clasp and the outer chamber, and the inner chamber is also inside it. The compression chamber handles the transfer of hot and cold air, and it exerts force on the piston, and the movement of the piston represents the change from thermal energy to mechanical energy. And here's the exploded view. You can see the outer cap, the outer chamber, and inside it is the inner cap, inner chamber, and then the outer clasp, and then the inner chamber seal, which keeps all the gases contained. Next, I'll pass it off to Nathan to talk about the flywheel.
Okay, so for the flywheel, this is the part that's connecting the motor and the gas chambers together. So there's some small parts that weren't particularly important. You have the bar that's connecting everything together. The circlip and small pin, which lock in the crank pin parts that actually are connected or holding in the motor and the compression chamber pieces. And then the flywheel shaft and the steering shaft, basically what's holding up the flywheel along the base plate. So the more important pieces, we have the crank pin to the displacer and the crank pin to the motor. Now these are essentially what's going to, your shafts that are connected to your motor and your compression chamber. As they rotate, they're not necessarily on the same axes. So with different sizes, the crank pins actually will put these on the same axes, and then that's how one will in turn rotate the other. And then another part is going to be the flywheel. The most important piece, essentially, this is what you can call the mechanical battery. The flywheels are supposed to be very large and heavy, so it takes a lot of energy to start them turning, but once they're in that turning, they can hold a lot of this rotational energy and makes it harder to stop. So they have a much larger capacity with a bigger wheel. And then I'm going to pass it off to Drew for the motor.
All right, so the motor is the final piece that connects the flywheel to whatever is our mechanical output. Designing the motor, it's important to keep in mind these cylinders here. They have to be dimensioned just right such that they both nest inside of each other, and they also have a specific minimum and maximum length. And here we have a pan of our full assembly.